Hello, in this video, we will introduce STL iterators. STL iterators provide a uniform way for traversing the elements in a container. Iterators are used extensively in the first-class containers for accessing and manipulating the elements. The first-class containers are the sequence containers and the associative containers. All these containers have the begin and end functions. The begin function returns the iterator that points to the first element in a container, and the end function returns the iterator that represents a position past the last element in the container. So look at this diagram here. That's the begin, and here is the end. Typically, you cycle through all the elements in a container using the following loop. So from the beginning and to the end, going through every element in the container and process the element at the pointer. Now you can also write for each loop to process all the elements in the container. Let's look at one example to demonstrate using the containers. We have this vector, push the integer into the vector. So now we are using this iterator P1. So what is P1 here? From the beginning and to the end. So with processing every element. So that is to display all the elements in the vector. So this is a set. And also here we will get the P2. So this is the beginning of this int set dot begin, and this is not the end, is int set dot end, not equal to the end. So now this is P2 plus plus. So please note that you can define this. This is the iterator here. This is P1 is the iterator in the vector class, and this is P2. This is the iterator in the set class. Let's look at the types of iterators. So there are five types. Input iterators, output iterators, forward iterator, bidirectional iterator, and the random access iterator. Input iterator. An input iterator is used for reading an element from a container. It can move only in the forward direction, one element at a time. Output iterator is used for writing an element to a container. It moves only in the forward direction, one element at a time. Forward iterator combines all the functionalities of input and output iterators to support both read and write operations. Bidirectional iterator is forward and also going backward. Random access iterator is the most powerful. It's a bidirectional iterator. Additionally, it can access any element in any order. You can jump forward and backward easily. So the vector deck support random access iterators. List, set, multi-set, map, and multi-map containers support bidirectional iterators. Stack, queue, and priority queues do not support iterators. So this is the table list of the containers and what kind of iterators they support. Now, let's look at the operations for the iterator. You can move forward plus plus p and p plus plus, and this is the input here is input iterator. So this is the reference iterator and used as R value from the right, you retrieve the value. So this is to test the iterator. Same or not same here. For the input iterator, you can do this. Output iterator, so this is everything before this. So this is the, so for the output iterator, you have the, this is the reference iterator used as left value. Bidirectional, so you have this minus minus decrement going to the left. Random access, you can, so this is the pointer, this is random access, the iterator, you can move anywhere to the right and to the left, and so you can return the iterator i's position after p, so this is the minus p and before p, so I positions, you can test the iterators, relational operators. Let's look at this operations for iterators. So here is the vector. Well, this is the vector here. Let's write some code right here for this. Is you can see that I'm going to go to the previous, and now I'm going to 3 positions left of P1. And this is random access. So this is, you can use the index using this from the end, 3 positions before the end. And this, you can assign a value and to this iterator here. So this is how you use the iterator. There are a couple of predefined iterators in the C++ library. The str containers use the typedef keyword to predefine synonyms for iterators. The predefined typedefs for iterators are iterator, const iterator, reverse iterator, const reverse iterator. The iterators are defined in every first class container for consistency. All of this are defined. So all of this are defined in the first class container. For example, here, now this is iterator. Look, this is the iterator in the vector class. And this is the iterator in the list class. And so now let's look at this example using const iterator. So now we have this const iterator for P2. So can you change the contents of P2 now? Not allowed because you're using the const iterator. Reverse iterator. So here we have this vector. Now this is reverse iterator. So this one here, you are getting this R begin. So that's reverse iterator. So now from the last, you go down to the beginning. So this is reverse end. That's at the beginning, past the beginning. So that's reverse end is 4. So this is this P1, it's plus plus because iterator, when you plus it, it's further and backward to the next one. So this is display everything now. Now let's look at this input stream iterator and output stream iterator. Iterators are used for sequencing elements. You can use iterators to sequence the elements in a container as well as the elements in input, output streams. So let's look at this program to demonstrate how to use this input stream iterator and output stream iterator. So this is the program. So enter 3 numbers. So you're going to use the cout. So this is the cout, enter 3 numbers. And now we are using this iterator here. So this is in the IO stream, the input iterator. So we're going to define this is the input iterator for cin. And this is the output iterator for cout. So now, see what you do here, you are getting from the input the value assigned to number 1. Now move to the next input, and the next one is now assigned to number 2, and move the next in the input, the next one is assigned to number 3. Now all of this, we get the max of all of this, max defined in the algorithm header, so assigned to the output. See, this is the effect, is like using C in and C out, but now you write it code in different way using stream, input stream iterator and output stream iterator. That is all for this section on STL iterators. See you on the next video.